In part B, even we don't know how to solve part A, it's still possible to solve part B1 here. First, suppose that the line, that means the tangent, pass through a certain point, which is 8, -7. 8, -7, so somewhere here. So from the graph, maybe it seems like it's not this tangent, but the green tangent. But anyway, just let us have an idea that there is a point, 8, -7, pass through the line L. And also, we have this point coordinate, which is 0, 5. We are going to find out R. Beware that in part A, we already find out the linkage between R and M. So by having 2 points here, then we can write down the slope of L directly. Slope of L is equal to the y difference, 5 minus -7, over the x distance, which is 0 minus 8. So we have 12 over -8, which is -3/2. This is the slope of the tangent. And don't forget, this is representing by m. With the value of m, then we just plug it in. There is an equation for r. So we have r squared equal to 9 times 3 times -3/2 plus 1 power of 2, and then -3/2 squared plus 1. So even though a little bit complicated, but we just simply use the calculator to get the value. It's become 9 times 49 over 4, and that is 9 over 4 plus 1. Both sides times 4 without changing values, so we have 9 times 49, and then divided by 9 plus 4, which is 13. We take square root out is equal to square root 9 times 49 divided by 13, or R is equal to the negative case. But we are talking about the radius, the length, so this is rejected. We have R equal to 3 times 7 over square root 13. Also, the question asks you to find out the value of R. So this is your final answer for part B1. You should rationalize it before you submit the final answer. That's why I multiply square root 13. It will make the denominator become rational. So we have 21 square root 13 divided by 13. Or just use calculator, we get R is equal to 5.82435206 ... And then we go back to part B. They are saying that R is a point such that C is inscribed in the circle PQR. First, realize where is PQR first. Y-intercept of L denoted by Q, so we have a point Q here. This point is point Q. Afterward, we have point P. Point P is the marked point here, so we have point P somewhere here. And then how can we draw a suitable angle so that this circle is inscribed in the triangle? The method is create a triangle and then start the line from point P and point Q. So basically, the question tried to describe that point R is somewhere here, such that the circle is just fit into this triangle. And then we are going to find angle PRQ. Our target is angle PRQ here. This is our target. In this graph, it's talking about the property of our in-center. For in-center, we are talking about from this point to center to the vertex of the triangle. We'll bisect the angle here. Basically, this property is come from the tangent from external point, tangent from exterior point. If we connect like this, then we will find that this triangle and this triangle are congruent. So there is a series of property. This angle and this angle are equal. That's why just now I say is bisect by the line connected from center to the vertex, and the radius is equal. The radius is obvious. This is tangent, so radius to tangent will be perpendicular to each other. And finally, this part from the touching point to vertex, are the same. But now we are focusing in angles, so I try to separate the triangle like this. Even though I have no idea how to find it out, but if we look here from point Q to the center, to the in-center, I can find out the distance by distance formula. At the same time, we already have R, which is found in the previous part of the questions. So in this right angle triangle, it's possible for me to find out this angle. Maybe I call this theta 1. Because it's bisect is theta 1 also. Similar reason, I can find out this angle if I want. This is theta 2. After I get theta 1 and 2, then I can use angle sum of triangle to get our target. This is our strategy. So we just focus in a single triangle first. Maybe we focus in this one. In part B2, maybe I let the center, let A be 9, 2. So just give it a name. This is point A. And then in this blue triangle, I can find out the distance of QA. With the distance of QA and also the radius, I can get this angle. So Q to A is equal to square root 9 minus 0 square and then plus 2 minus 5 bracket square. We get square root 90. Afterward, together with the results that R is equal to 21 over square root 13, then we can calculate the theta 1. Let angle AQR equal to theta 1. We have the opposite side, we have the hypotenuse, we are going to use the sine ratio. Sine theta 1 is equal to opposite, which is R, divided by QA. We'll get sine theta 1 is 0.613940613 something. And then we just take shift sign, then we reverse. We get 37.87498365 something. After that, we are going to do the same for theta 2 here. So maybe this time I consider this red triangle. I can find out the direct distance between P and A, and also I have the radius, so it's possible for us to find out theta 2. We get PA directly. 9 minus 8 bracket square, and then we have 2 minus negative 7, then we plus 7 bracket square. So we got PA is 82. Similar reason, R is equal to 21 over square root 13. And we let this angle, so maybe we let this angle is angle APR equal to theta 2. Sine theta 2 is equal to the radius divided by PA, so we just use our calculator. Finally, we get theta 2, which is 40.0302592 something. Finally, our target angle PRQ is just equal to 180 minus 2 theta 1 minus 2 theta 2. Therefore, the result is 24.189511415 something degree. That's our answer. A very important thing to understand this is you must draw properly. Have an idea what to do, and also you have to understand which one is locked, which one is not locked, so that you can build up the triangle by yourself.